Explain the following. A. Frequency division multiplexing. Frequency division multiplexing is a networking technique in which multiple data signals are combined for simultaneous transmission via a shared communication medium. Right? FDM uses a carrier signal at a discrete frequency for each data stream and then combines many modulated signals. FDM allows multiple users to share a single physical communication medium. Right? This is the figures for the frequency division multiplexing. Right? Then next one is synchronous time division multiplexing. Synchronous time division multiplexing. In synchronous time division multiplexing, each device is given same time slot to transmit data over link. Irrespective of the fact the device has any data to transmit or not. Hence the name synchronous TDM, synchronous requires that total speed of various input lines should not exceed the capacity of path. Each device places data onto the link when its time slot arrives. Each device is given the possession of light turn by turn. If any device does not have data to send, then its time slot remains empty. The various time slots are organized into frames, and each frame consists of one or more time slots decided to each sending device. This is the synchronous time division multiplexing. Statistical time division multiplexing, statistical TDM. STDM, statistical time division multiplexing, is a method for transmitting several types of data simultaneously across a single transmission cable or line. Right? This is the statistical time division multiplexing. Well, you can see in this figure. Orthogonal frequency division multiplexing, OFDM. Orthogonal frequency division multiplexing is a technique method or scheme for digital multi-carrier modulation using very closely spaced carrier, a previously modulated signal modulated into another signal of high frequency and bandwidth. Each of these subcarrier contains number of parallel data streams or channels and is modulated conventionally at a low symbol rate. These are group of bits of data related to but not the same as cross bit rate, which is express bit rate. This is the orthogonal frequency division multiplexing figure. Right now you can see frequency. Next one is frequency hopping spread spectrum, FHSS. Frequency hopping spread spectrum is a method of transmitting radio signal while shifting carrier across numerous channels with the pseudo-random sequence, which is already known to the sender and receiver. Frequency hopping spread spectrum is defined in 2.4 GHz band and operating around 79 frequency ranging from 2.402 GHz to 2.480 GHz. Every frequency is DFSK modulated with a channel width of 1 MHz and rate defined 1 Mbps and 2 Mbps respectively. This is the depicts the FHSS transmitter and FSSS receiver block diagram. Right, this is the transmitter. This is the receiver. Direct sequence spread spectrum. Direct sequence spread spectrum is a transmission technology used in local area wireless network transmission. In this technology, A data signal at the sending station is compiled with the higher data rate bit sequence, which divide user data based on splitting ratio. The benefit of using DSS are resistant to jamming, sharing single channel among multiple users, less background noise, and relative timing between transmitter and receiver. This is the figure for the direct sequence spread spectrum. The next one is explain the transmission media characteristics of twisted pair cables. We can divide the transmission media into mainly two parts: guided transmission media and guided transmission media. Guided transmission media means wire media. In this transmission media, twisted pair cable, coaxial cable, optical cable, fiber are coming under the guided transmission media. Twisted pair copper cable. Twisted pair is the ordinary copper wires that connect home and many business computers to the telephone company. To reduce the crosstalk or electromagnetic induction between the house wires, two insulated copper wires are twisted around each other. Consist of two insulated copper wires twisted together. Can be used for either analog or digital transmission. Twisting reduces the effect of external interferences. To avoid magnetic field effect, the wires are twisted. Common application: telephone system lane. Two types: sealed twisted pair cables and sealed twisted pair cable. STP, UTP. Characteristics of UTP: speed. This is the speed of the UTP. Least expensive. Maximum cable length is 100 meter. Media connector size is small. Characteristics of STP: speed 10 to 100 Mbps, moderately expensive, maximum cable length is 100 meter. Similar in construction of the next. Coaxial cable has a single copper conductor at its center. A plastic layer provides insulation between the center conductor and the provided metal sheet. The metal sheet helps to block any outside interferences difficult to install. Fiber optics. Fiber optic or optical fiber refer to the medium and technology associated with the transmission of information as light pulses along a glass or plastic strand or fiber. Fiber optic cable can contain varying number of these glass fibers from a few up to a hundred. Surrounding the glass fiber core is another glass layer called cladding. The layer known as the wafer tube protects the cladding, and jacket layer acts as the final protective layer for the individual strand. Is the capability to carry information at vastly greater speed. Consists of extremely thin cylinder of glasses called core surrounded by cladding, more lightly expensive than 251 transmit one receiver. Higher secure from outside interferences such as radio transmitter. Advantages of fiber optics for communication: more lower level signal attenuation. Fiber optic cabling provide much higher bandwidth, allowing more data to be delivered. Fiber optic cables much lighter than coaxial cable that might otherwise be used. Characteristics of fiber optics. Fiber optics operates in the visible light spectrum in the range from this is the range. Wavelength will measure the width of the waves being transmitted. Different fiber optic materials are optimized for different wavelength. The next one is radio, wireless. Wireless transmission is the form of unguided media. Wireless communication involves no physical link established between two or more devices, right? These are some wireless media: radio wave, microwave, infrared, ultraviolet, X-ray, right? Transmission. Radio frequency is easier to generate, and because of its larger wavelength, can generate through the walls and structure like radio waves can have a wavelength from. This is the range, right? radio high frequency as proved to be absorbed by train and other struck. They use ionosphere of the Earth's atmosphere high frequency radio wave. Mostly radio broadcasts are sound through the air as radio wave. Radio is a transmitter which transmits the data in the form of radio signal to the receiver antenna.